Okay, guys. Today we are going to discuss the detailed uh, coding of k-nearest neighbors and locality sensitive hashing and carrier trees. Okay, so guys, um, okay, so guys, first of all, we will start with k-nearest neighbors. Okay, as I told you that k-nearest neighbor is a retrieval algorithm. Okay, it is a retrieval algorithm. So what do you mean by retrieval algorithm? Well, to k nearest neighbors, you have to give one example as an input, and what k nearest neighbors will do for you is that it will retrieve for you. Retrieve for you से मतलब है कि वो निकाल के देगा आपको. It will retrieve for you k closest examples to the input example you have provided it to the algorithm. ओके सो गाइस अब हम ये काम कैसे करेंगे वेल उसके लिए हम एक छोटा सा एग्जांपल लेने जा रहे हैं गाइस so what I'm going to do is that I'm going to take okay, so I'm going to take first I'm going to log into Jupyter Notebook so that I can code in front of you. Okay, and now what I'm going to do is I'm going to start coding k nearest neighbors. Okay guys, so I'm going to import the library. Okay, and now I'm going to read the data. Okay, so raw data dot head, and let's say I'm going to get rid of date, time, season, holiday, working day, weather. Okay, so raw data dot drop. Okay, raw data dot columns 0 to 0, 1, 2, 3, 4. Okay, 0 to 5. X is equals to 1, in place equals to 2. Okay, Now if you see the data, so guys, we have four features. Okay. Now suppose if I take a testing example out of the k nearest out of this data set. So testing example equals to raw data dot hilock raw data. Okay, raw data. Sorry. So np dot random dot rand int. I'm just going to take a random example 0 comma raw data dot shape 0. Okay, so let's see our testing example. Okay guys, so this is our testing example. Now what I want to do is I want to find the 5 closest or 5 nearest examples to this example. So for me k value is equals to 5. Okay, k is equals to 5. And guys, now what I will do is I want to find the 5 nearest, and how I will determine that whether it is the nearest or not. Okay, how I will determine, guys, what I will do is that I will actually compute. Okay, so I will compute distance of my testing example with all of the examples and select those 5 examples for which we have the smallest distance. Okay, so guys, every single example is a vector. It's a row vector. So like we have 4 features, so it's a 1 cross 4 row vector. Okay, so what we need to do is we need to find the distance between 2 vectors, and we have to select those 5 vectors for which the distance between our testing example, which is our 1 vector, and the distance between all the other examples. So we have to select 5 such examples out of all the examples for which the distance between the testing example as well as the other examples will turn out to be the lowest. Okay, तो गाइस इसका मतलब हम क्या करेंगे, अगर हमारे पास डाटा फ्रेम है और हमारे डाटा फ्रेम में 4 फीचर्स हैं और बहुत ढेर सारी रोज हैं और यहाँ पे हमारे पास एक टेस्टिंग एग्जांपल है, और गाइस टेस्टिंग एग्जांपल में हमारे पास एक रो है जिसमें 4 फीचर्स हैं, so it's a 1 cross 4 vector, and like that this is 1 2 3 and like that you have how many rows. Let us see how many rows. So raw data dot shape, so there are 6493 rows. Okay, 6493 rows. So 6493 rows, and there are 4 features. So it means it's a matrix. It's a 6493 cross 4 matrix. Okay. Okay. So 6493 into 4. Okay. And we have to calculate the distance between every one of these vectors with the testing example. Okay, distance between two vectors. How will calculate the distance between two vectors? Guys, this vector minus this vector and each component to the square. So it means if I subtract this vector with this vector, I will again get a 1 cross 4 vector, and I will take the square of each of these and add them and take the square root. That's a magnitude, right? That is a distance. Okay guys, so this is what I'm going to do. Okay, but first let me drop a specific let me drop that specific testing example. Okay, so let me just take it here. Index of testing example. I'm just giving you an example, guys. Okay, index of testing example, and then this will be given by np.random.randint 0 comma raw data dot shape 0. Okay, and I will take it here. Okay, index testing example. Okay, so guys, what I want to do is, अब मैं क्या करने जा रहा हूँ यहाँ पे, मैं वो इंडेक्स हटा दूंगा अपने डाटा सेट में से जिसके लिए मैं चेक कर रहा हूँ, क्योंकि उस वो इंडेक्स भी अगर आ जाएगा तो उससे तो फिर डिस्टेंस जीरो हो जाएगा, तो उसका मतलब टॉप मोस्ट पॉइंट वो होगा, लेकिन हमें क्लोजेस्ट पॉइंट निकालना है क्योंकि उस पॉइंट का उस सेम पॉइंट से डिस्टेंस तो जीरो हो गई, राइट? सो वी आर नॉट गोइंग टू डू दैट. सो ड्रॉप. ओके, ड्रॉप. Okay, and I'm going to pass the index. Okay, comma x is equal to 0, because now I want to remove the whole row. Okay, I want to remove the whole row. In place equals to true. So let's see, guys. Okay, so before there were 6493 rows, now there are 6492 rows because I have removed the same row of the data which I have taken to be the testing data. Okay, now I'm going to find the closest 5 matches. Okay, so how I will do that? First of all, convert it into array. So raw data array equals to np dot array raw data. Okay, and now what I'm going to do is distance of each example equals to testing example minus raw data array Okay, so what will happen is the array will get broadcasted. The 1 cross 4 row vector will get broadcasted and the subtraction will take place with every single vector. So, okay, so it's giving me, oh, okay. So testing example is, I should convert it into an array. So testing example equals to np dot array. Okay, testing example. Okay, dot reshape. Okay, 1 comma testing example dot shape 0. Okay, so guys, we have computed the distance, not the distance actually. We have to now take the square root of the square of every element. So first we have to take the square of every element. Okay, but first let's check the. Okay, okay guys. So guys, यहाँ पे वो क्या रहा है कि हमने हमने क्या किया कि हमने इस वेक्टर को, ये जो आप वेक्टर देख रहे हो, सो इसका मतलब हमारे पास 6492 इन क्रॉस 4 का एक एरे था. Okay, so this is 6492 rows and there are 4 columns. Okay, minus there was this row vector 1 cross 4. Okay, and we subtracted the vector from every single vector, so it means this minus this, 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 and because of array broadcasting, the subtraction took place on all the 6492 rows. And because there are same number of columns in both the arrays, 4 number of columns and 4 number of columns, so the subtraction will take place on every single cell. So this cell minus this cell, this cell minus this cell, this cell minus this cell, and this cell minus this cell. Okay, similarly for the bottom row, this cell minus this cell. Okay, this cell minus this cell, this cell minus this cell, and this cell minus this cell. Okay, so what we are getting right now is the distance. It's inside this variable distance. Okay, distance of each example. So distance of each example. Okay, so distance of each example. Okay, so guys, let's take distance between these two arrays, and we have already got 6492 cross 4 array. Okay, so guys, now what we are going to do is, so let's say you have got a matrix of two arrays or two row vectors, and I have a testing vector. So that's 3, 4, 5, 6, 7, 8, 9, 10. So this is one vector, and here is another vector, and this is my testing example. So 1, 2, 3, 4. Okay. So what I did right now is this minus this and this minus this. So I will get again a vector of 2 cross 4. So 3 minus 1 is 2, 4 minus 2 is 2, 5 minus 3 is 2, 6 minus 4 is 2, 7 minus 1 is 8, 7 minus 1 is 6, 8 minus 2 is 6, 9 minus 3 is 6, and 10 minus 4 is 6. Okay, so we have two vectors which are the subtraction of all the vectors from testing vectors. Okay, and now what we are going to do is we are going to take the square of each element, and we are going to add them up. So 2 square plus 2 square plus 2 square plus 2 square, this will give me a separate number. That's 4 plus 4 plus 4 plus 4. 4 into 4 is 16, and 6 plus 6 plus 6 plus 6. So that's 6 square is 36. 36 into 2 is 72. 72 into 2 is 144. So that's 144. Okay, but now we have to take the square root. So I will get 4 as an answer here, and I will get here uh, some root 144. Okay, so this is what we have to calculate. So this is the distance of the testing vector from first vector, and this is the distance of the testing vector from second vector. This is what we have to do. So we will get 6492 numbers. Okay, so guys, this is what I'm going to do now. So what I'm going to do is distance of each example equals to distance of each example square. Okay, and what we have to do, guys, we have to take the sum. Okay, and we have to take the sum. How we have to take the sum? X is equal to 1. So distance of each example equals to np dot sum distance of each example comma x is equal to 1. Okay, dot shape. So I'm getting 6492 distances. Okay, but these are the squares. Okay, so now what I'm going to do is distance of each example equals to np dot sqrt distance of each example. Hmm? Okay, let's see. Okay, guys, so these are the distances. Okay, so we are getting the distances. Now we have to select the top most 5 values, or you can say topmost 5 indices, because we need to know the locations of those points at which we are getting the least distance. So what we will do is, so nearest neighbor points equals to np dot argmin. Let's see what is the meaning of out. Okay, so argmin distance of each example x is equal to, we don't need any access, out equals to 5 comma 1, or you can say capital K comma 1. Output must be an array. Huh. Okay, numpy mp dot array. Okay, it's not letting me do that. Okay, so what we can do is we can just say, okay, so if we put here raw data dot ilog, so nearest neighbor, so this is my point, guys. This is my nearest neighbor point. Now what I can do is I can remove this point and I can check for the second one, nearest one. And similarly, we'll keep on removing any point for which we have evaluated the shortest distance and for which we have got the index. We'll remove that point from the data set so that we always get a new point. Okay, so guys, this is k nearest neighbors. Okay, this is k nearest neighbors.